And we're live.
Woo!
Hello to all you out there, GCP online meetuppers. Thank you for joining us today. My name is Anthony Bouchon, and I'm a customer engineer here with Google. And we have some exciting stuff for you today. If you can't see already, we got a couple interesting tabs, but Jonathan Cham, our presenter today, will be diving into that. So, Jonathan, you want to introduce yourself?
Yeah, Jonathan Cham. I'm a customer engineer here at Google, and typically I'm the host, but I'm getting reverse hosted, I guess, today.
This is true. This is true. I'm the backup host, so I'm not sure you can expect as you can expect the second best jokes today. So yeah, it looks like you have some exciting content. I'm reading Hotdog Part 2, and the Getting Started with Machine Learning on GCP. Let's dive right into it.
Yes. So, I mean, this is going to be earth-shattering demo that you all are going to see. But I mean, Anthony, you should probably be asking, why am I the right person to be talking about ML? Like, you know me, I don't have a
Right.
PhD in mathematics. Yep.
I
And
think
yeah.
I mean, I think it'll be pretty telling if you can teach us a thing or two on ML without a PhD. I'll be pretty impressed.
Yeah, exactly. And I mean, getting started with machine learning, I thought, oh my gosh, like a lot of the books have a lot of algorithms. I mean, there's just so many pieces to machine learning. But what I found is that a lot of my customers who are doing machine learning don't actually have that like higher degree of math just to do machine learning. I think a lot of the research and a lot of the difficult, the complexity has actually been done. Now, if you're trying to identify new methods of machine learning, then yeah, you'll probably need that higher level mathematics degree. But a lot of these things we can actually do on our own, and things like TensorFlow allow a lot of abstraction from the underlying complexity and allow us to build really cool things. So I think one of the takeaways I've seen from many people doing machine learning is you don't need a PhD. And I think actually one of the Google Next presentations was TensorFlow or machine learning without a PhD, and I think that's totally accurate. So I
Yeah,
really like.
definitely. I mean,
Yeah, Anthony, what were you going to say?
oh, sorry. I think I didn't mean to cut you off. Just said definitely excited to see what you have ready for us today. So
Yeah, absolutely. And I know we're 3 minutes in, so some people don't have high attention spans. So if you need to leave right now, this is all you need to know, right? What with Google Cloud Platform, we obviously invest a lot into machine learning. And one of the things that we're really excited about is Google Cloud Datalab, which is an IPython notebook that lets you quickly move from research to production in a single interface. So for those of you who are familiar with IPython or not familiar with IPython or the Jupyter Notebook, it's really an interactive tool, a web-based tool that allows you to kind of step-by-step through certain Python commands. Now, if you're developing code with Python, developing a web app, you typically don't do that, step-by-step interactive mechanism of troubleshooting code. But in machine learning, what you'll find is that you do a lot of things, kind of you're tuning a lot, you're changing a couple things here and there, and you're running the same lines of code over and over, which makes Jupyter Notebooks and IPython really aligned to the machine learning process. And so basically, Google Cloud Data Lab is the IPython notebook, and I'll show a quick demo of how that's done today. And Data Lab is built in libraries to access everything internal. And with machine learning, as you really start building out a real production like machine learning application, you're going to need those cloud resources. Things like your laptop are not going to support your machine learning model in production. I don't know, Anthony, what have you done so far to learn about machine learning?
well, I was hoping to attend and watch you. No, but I mean, I think that I have had a little bit experience with Jupyter Notebooks as well, and I think that really the ability to embed code with I tend to learn things from kind of a very textbook like interface, and when you can actually run code from kind of learning interface, it's
Really
way
easy.
easier to comprehend. I'd also say that this is open source, right? And this is something that you could run elsewhere as well. But when it comes to utilizing cloud resources like you're discussing, I think Data Lab is great.
Yeah, great note. Actually, I forgot to put that. So Data Lab is open source. If you just search Cloud Data Lab on GitHub, all the code is there and everything that I'm doing today is run on Cloud Datalab. So you'll see everything there. I think, for me, the fastest way to learn was to go to kaggle.com/kernel. So Kaggle is a crowdsourcing machine learning platform. And the highest level is, you're a business, you have a machine learning, or you have an idea, you want to do some sort of predictions. You put out some prize and you have all these great data scientists from all over the world competing to find the best model that allows them to predict whatever use case they have. So what Kaggle has done is they've actually have people who have open sourced or exposed exactly how they've done the kind of the data exploratory data analysis, things like showing their notebooks. So you can actually see how the best scientist, best data scientists are looking at data. How are they evaluating it? How are they manipulating it? And a lot of this is actually data
Wow.
wrangling, right? How do you data wrangle all of this information? So definitely
Wow.
go check.
So basically within Kaggle, there's a lot of notebooks that are already built out by other data scientists, and you can pretty much, kind of learn and mess around with what they've already built.
Yeah, that's exactly the case. And I mean, for
That's
me,
awesome.
yeah, I have mine open, but they're pretty pathetic. And so I don't think anyone's actually looked at them. So yeah, I mean, it's got an upvote system, right? And so people who upvote certain notebooks are going to be the ones that are typically the most comprehensive, most thoroughly documented. And I've actually learned a lot through that, better than reading books. You notice that the fastest way to learn, I did not put read a book. That I actually had that in there because I did start reading, but I found that reading is nothing like actually running through code yourself. But anyway, similar to Kaggle, right? Data Lab, samples directory, and the GitHub Google Cloud Platform, we have a lengthy list of samples for Data Lab and using Cloud Machine Learning Engine.
Yeah, so it's almost like the best of both worlds there, right? You're able to kind of get a textbook experience from what you're writing within the notebook, but also to be able to execute code and run through it, you're able to do, right?
Yeah, and so what I found is when I run through the Data Lab notebooks and I run through the code, I usually have questions. Like, if you're like me, you really want to understand like what is going on behind the scenes. So at that point, I'll read some, I'll say, hey, we're doing gradient descent. What the heck is gradient descent? What is that? So I'll, kind of look online or read a book about exactly how that's done. But in the end, a lot of the practical work is actually done in the notebook. So it's basically do, do the exercise and then figure out why it worked later, right?
Yep. Cool. So tell us what we're looking at.
Well, I know, recently there's been a lot of hype about hot dogs or no hot dogs. I know I'm a big fan of the HBO Silicon Valley show, and I figure, I want to figure out how that's done. And there's actually a really good article if you just search. I think I'll have the link later for everyone. But the creators of the Hot Dog No a Hot Dog app on this Silicon Valley show actually went through a very lengthy technical process, and ultimately they decided to write their own convolutional neural network in Keras that allows them to reduce the size of the model. So their model runs on a mobile phone, right? And whereas the model I'm showing you today is actually run on Google Cloud Platform. So it's a little bit different, but that's essentially why they decided to write their own model.
Awesome.
All right. So before we jump into the demo in 1 minute, I promise, because I'm always pestering people to get to the demo. But yeah, machine learning is easy with small data sets, but obviously you need a production-like environment, and that's where Google Cloud comes in. Keeping a consistent machine learning environment, very important. And just the fact that when you are starting to train and evaluate and your data just grows enormously, you just can't possibly do everything on your laptop. So, in the end, Data Lab, why TensorFlow? TensorFlow is great for training and serving production models. And these are all things that kind of are challenging today, but we're trying to address with Google Cloud Data Lab and all our cloud ML products. Okay, let's get to it. Any questions so far, Anthony? Are you excited?
I'm so excited.
You're so excited. All right, so real quick.
I think I have some trouble with identifying hot dogs or not hot dogs, so it's good to see that this demo can help me out.
Yeah, fantastic. So I'm not going to show you the terminal stuff because that's really kind of bland, but anybody can create a data lab notebook. All you have to do is download the G Cloud or I think they call it the G Cloud SDK. Is that right, Anthony? They name it a couple. Okay, G
Yep,
Cloud
that's
SDK.
correct.
That comes with data lab. All you need to type is data lab create, and then the name of whatever instance you're doing. So once you do that, it'll actually spin up a data lab instance and it'll pop up a browser window, and that's it. It's literally 3 words: data lab create, POC or something. And POC is a compute engine instance that spins up with all the necessary data lab libraries and TensorFlow libraries and everything you need to do with machine learning. All right, so time for the demo. So let's jump here to, this is the first version, and I'm showing you this first version, and I'm not going to actually go into all this yet, because in the next version I will explain. But what do you see wrong with this right now, Anthony?
Well, that's definitely not a hot dog. And I know I said I had some troubles with it, but those are definitely taquitos.
Yeah, so the first model I trained, it wasn't very successful. And I'll talk about the training process later. But I was really excited. I collected a bunch of hot dog photos and I trained my network, and boom, I was like, oh yeah, it's really good at classifying hot dogs. Because look, you look at the bottom, boom, that's definitely a hot dog, right? I mean, 99.98% hot dog. That's pretty good. But this actually kept me up at night. I mean, 100% confident that this is a hot dog. And those taquitos with cilantro on top are definitely not hot dogs. And that really bothered me. Actually, it kind of ruined my 4-day weekend, believe it or not.
Well, I mean, can you walk us through the architecture that you use to kind of, or the process that you use to train this model, or are we going to get to that?
Yeah. Let's do that right now. So obviously this did not work. And I said, we're not showing this. So part 2, right? You see at the top, part 2. Now, this is the Jupyter Notebook. For those of you who know Jupyter or IPython Notebook, I mean, there's nothing special about this. I think what's really special about what we're doing here is that we've already built in all these libraries to leverage things like BigQuery, Google Cloud Storage, Dataflow, CloudML. I mean, it's all built in with very simple API calls, right? And like I said, there's a lot of other machine learning platforms like scikit-learn, Keras, uh, you know, obviously TensorFlow. But one thing that's kind of unique about TensorFlow is that you can move from kind of a test dev or just kind of experimental phase into production very quickly. And we'll talk about that.
That's awesome.
Yeah, I mean, it's to be honest, I was actually very surprised at how far this has come. I know I used this about, I think, half a year ago, or even earlier than that, and it wasn't as full featured. But I mean, this thing is growing so fast that I was able to use this and do something very useful, like classifying hot dogs.
Right. So really, Datalab is something that's extremely useful if you're working with other Google Cloud Platform resources, right? Because it looks like you're importing all these respective libraries that are native to Datalab, whereas I think if you're using Jupyter Notebooks elsewhere, you'd have to kind of rig together the client libraries to be able to use things like BigQuery or things like storage, right?
Yes, that's exactly right. I mean, before
Awesome.
before actually using Datalab, I ran the open source notebook, and the problem with that is obviously you can run a lot of the cool things all locally, right? So imagine that you're in a team and you have all these images that you've downloaded on your local laptop. Well, how does your team member work with all those images? Well, you kind of have to maybe ship them a USB drive. I mean, you have to somehow share it. With Data Lab, we have Google Cloud Storage libraries in here already. So typically, the right process would be to store everything in the cloud. That way, you guys can all share the data sets, and everything is run in the cloud, so multiple people can work on the same models, same images, same data, without having to waste time with shipping back and forth the data.
Got it.
Yeah, so you can hear, I mean, I'm just import. I mean, a lot of these actually I don't need, but a lot of these like matplot image, I mean, a lot of these are actually libraries that you probably wouldn't need in a full production environment. This is just for demonstration purposes. So yeah, import the libraries, define some of the variables. I have worker directories where the model is going to be saved, where the images are saved. And the first thing I think you asked, like, where do I get all these images, right? And actually, at first, I was going to write some kind of scraping script to go to Google Images, find hot dogs. And yeah, that just took too much time. So I did a quick Google search and boom, there's actually an open data set for images that are already labeled, which is great. So you can see that actually within the Jupyter Notebook, I can actually query BigQuery. So you can see what I'm doing is in this data set called BigQuery public data, and actually any of you listeners can go to this data set. It's called BigQuery public data dot open underscore images. And there are 3 tables in that data set. There's labels, images, and I think there's a dictionary table as well. And there's, I want to say, tens of thousands of images there that have over, I think, a couple thousand classes. And some of them were hot dogs, taquitos, things like that, right? So, and on top of that, so I didn't show everything I did here, but basically I went to this open data set, grabbed a bunch of images, hot dogs, non-hot dogs at first, and you can see the result from the initial training was that I didn't put in taquitos and things that look like burritos or things that look like hot dogs, for example, sausages, right? So
Right.
in this new data set, I trained the model to basically for sausages are not hot dogs, taquitos aren't hot dogs, burritos aren't hot dogs, like anything that could look like a hot dog that is not a hot dog. I trained it so that it's not a hot dog. All right.
That's amazing. And so you are using TensorFlow to
Yes.
is that
And
correct?
yeah, we're using TensorFlow.
Awesome.
So right now you can see that all I've done is these are just picking out the images. And this is what the data set looks like after filtering out. So I have a URL to staticflickr.com, blah, 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 label name. And I basically kind of, manipulated all that data and turned it into something that looks like this. So you can see here that I'm reading the training file that I've created, which looks like this. You can see here, this is all on my local laptop. And I'm doing this locally so that's faster. But typically you would probably do this in Google Cloud Storage, especially if you have, terabytes of data.
Gotcha.
But yeah, underneath this, you have all these label names like no hot dog. And, you can see that I have about 1,700 rows. So I have 1,700 URLs or pictures with labels. Okay. Does that make sense so far? You following?
Yeah.
All right.
I'm with you.
All right. So just samples of images, right? So this is off topic. So again, all of this is done from the Jupyter Notebook. You can read from BigQuery. So what I did was I queried my data set where I put all my images, and just to get a sense of here's are all the different things that are not hot dogs, right? And I'd be very concerned if a hot dog did appear here because that means my labels were wrong. But this first one is just a
Right.
bunch of, I don't know, pitas. This one looks, I mean, this one, I could be fooled, I guess, if I was kind of maybe couldn't see colors, but this is broccoli in like a hot dog bun.
The
Egg
bun
rolls.
throws it off.
Yeah, exactly. And I actually don't know what that last one is. What do you think that is?
So I'm not sure, but I do have a question though. So
Yes.
essentially these are from that initial model that you had, this gave a confidence over, is that 75% I saw?
Yeah. So
in that query. Okay.
Yeah. So in that data set, there's actually confidence intervals of how confident, so there was another machine learning model that helped classify, and I think there were some humans involved, but I wanted to make sure that it was at least 75% confident that it was not a hot dog, right? So I think that, I mean,
Got
this
it.
is all subjective. And I think in machine learning, you'll learn that there's a lot of parameter tuning, right? If I had set that to 80 or 85,
Sure.
maybe my model would have performed better, maybe not. Who knows? So I think it was a good balance between, the more higher confidence you have, the lesser amount of images you'll have as well. So there's kind of a balance there.
Okay.
All right, so create training data set. And this is within Jupyter Notebook. What I did was there is a library called CSV dataset. And all it does is it puts that set of files, right? That local train file, which I had, which showed the link to the image as well as the label. I define the schema, all right? And this is used to pre-process. And what pre-processing does is in machine learning, especially with image detection and classification, ultimately what needs to happen is these images need to turn into a bunch of numbers, right? And what those these images are basically, underlying are just arrays, large arrays of numbers that determine, the pixel color and things like that. And so we're taking this data and we run this command called model.preprocess, right? And what you see here is that it's taking this training set, putting all this pre-processing data into the pre-process directory, okay? And what that does is just spits out a bunch of, I think, TF records. And so TF records are ways that TensorFlow stores data, but just imagine it as information that it has about all these images. So it's basically a bunch of numbers and the schema. Okay, make sense so far?
Mm-hmm.
All right. Now, model train, here's what we're doing is that we're actually training it. So here, what happens is we make some assumptions, right? And this is the benefit you get with abstraction. The assumption is that, this is using a convolutional neural network, and it's going through, um, I want to say like it's going through 800 iterations, right? With a batch of 30, and it's going to spit all this in a model directory. So this model will actually split up that entire training set into a 70-30 split. So 70% will be training and 30% will be for evaluation. Got it?
Got it. Yep.
Summary. So this is really simple, just kind of what was spit out during that training process. And you can see that the plot, right? After 800 iterations, my loss was almost at 0 with the training data. And evaluations did pretty well, actually, about 20% loss. So what we can do here is we can actually start TensorBoard. Let's start TensorBoard here. Okay. And to be honest, TensorBoard is like way above my head right now, but I just wanted to show you for people who are interested. This is exactly,
Sure.
behind the scenes, what's going on with TensorFlow. So if you're like really as you get into putting your model into production, you're going to need tools like TensorBoard to troubleshoot exactly what's going on. Maybe we'll do another session on TensorBoard later, but the fact is with TensorFlow, you can have this nice visualization of what's going on behind the scenes is actually very helpful for troubleshooting.
Awesome.
All right, so sanity check, right? So after I trained my model, okay, I gave it an image, which I knew was not in the training set, and I am 100% sure was not a hot dog. So this flower, okay, did a prediction and said it was 99.9% not a hot dog.
Yep, that's pretty confident.
Yeah, I think you would agree with me there. That daisy is not. So I said, okay, this is good. Let's move on to a batch predict, right? So all I'm doing is I'm just dumping in a list of images that shows a bunch of images that were not in the training set or evaluation set. So what I did was I went into Google Images, downloaded some random images that I thought could fool the classifier. So first one, this is actually tricky. I don't know if you agree with this, but not hot dog and hot dog. So this is the actual app from the Silicon Valley show, right? And I mean, to be honest, if you ask the human, is this a hot dog or not? I don't know. Anthony, what do you think?
That's, it's a very nice looking dog. I don't know about a hot dog.
But I mean, there was a picture of a hot dog though, right? So you can't blame the machine for thinking that there is, So the machine says, or the model says it's 84% not a hot dog, right? So there's a 26% confidence that it might be a hot dog, which I think is reasonable, right? You know what I mean? I mean, there's a picture of a hot dog, although it's a small part of the image. So I was okay with that.
There's some uncooked hot dogs there too.
Yeah. I mean, uncooked hot dogs. Do you consider that a hot dog? I would consider a hot dog. All right. So back to the taquitos. Okay. So 99.98% not a hot dog, and I would expect that, right? Because what do? We put it in the training set, right? So that's expected. Not a hot dog, and I'm very glad that is not a hot dog. All right. Back to this hot dog, 99.6%. So you notice that it actually I think it went down a little bit. Let me see from the other one, 99. Oh, actually, yeah. See, you notice in this previous model, 99.9% chance hot dog. This is 99.6% hot dog. So you notice that as I added more training data in, it actually decreased the confidence level of a hot dog by a little bit, right? By basically negligible amounts, but it did. But it shows you that the model is working, right? It's looking at a lot more data, and it's saying that, well, I'm still sure this is a hot dog, but because I have more data, I actually think that there's a smaller chance that this might not be a hot dog, but 99.6% chance it's still a hot dog.
Yeah. So is that like a trade-off that people are typically dealing with when training models, looking at, okay, I can take this approximation as far as confidence score just to improve, let's say, a certain situation where it's recognizing a taquito, right?
Mhm.
Like these are these trade-offs that people are making when they're thinking or deciding how to train and set their
Oh
parameters.
yeah, absolutely. I mean, and it also depends. Like, you might, 0.2% is probably nothing for most people, but maybe for some classifying, like it
Mhm.
really depends on the application, right? Like some customers are okay with if you give me a
Right.
51% chance that this is, X versus Y, I'm super happy with that. Anything above that, wow, that's great. But any prediction is better than no prediction for some customers, and so yeah,
Got
I
it.
mean, just I think the underlying I guess, the takeaway is really, the more data you have, the better. I think that's just the
Sure.
kind of the fundamental root cause of all issues with machine learning models is not enough data. All right, we'll
Right.
keep going down. More pictures. Guy eating hot dog, 99.6%. I think that's pretty good, right? I mean, any human would say, yep, that's
Yeah.
a hot dog, except there's a human in there. So, should we decrease that confidence level? I don't know. That's something that, you know, based on what your what your application is, you would retrain the model. But I mean, for my purpose, right? Is this a hot dog? Yes. So
Mhm.
I'm happy with that. Now I'm really surprised here. This sausage, I mean, I could be fooled by this. I mean, if you told me it was a hot dog, I wouldn't think twice. But the model said it's not a hot dog. It's a sausage, which is awesome, right? That means I trained it really well to distinguish between sausages and hot dogs, right?
Yeah, that's pretty
Yeah,
cool.
I was really surprised. I mean, and that's the thing about machine learning is a lot of it is, oh wow, that worked, great. And people will agree that it's very hard to know exactly why it worked, but
Uh-huh.
a lot of it is, back to the data.
You know what's interesting too. I know that
Yeah.
I mean, hot dog, not hot dog is kind of a trivial use case, but I
Yes.
think I've seen like a handful of people apply very similar kind of workflows and applications to things like recognizing um, anomalies in someone's x-ray or something like that, to be able to detect if someone has something wrong with the inner of the retina or something like that,
Hmm.
being able to like apply this same process. And there are, I mean, just unbelievable amounts of use cases that are out there that are going to change our world. Not to be
Yeah.
over dramatic, but
No, I mean, actually, I think, in my opinion, I think, I mean, I see a lot of use cases around pathology, right? Like you said, X-rays, cancer
Mhm,
detection. I think there was a diabetic retinopathy, right? Taking eye scans
mhm,
of the eye and being able to detect, diabetes, something like that. I mean, with image recognition and image classification, it's getting so good that it's really going to change that industry, the pathology industry. So, yeah, I mean that's great for healthcare, right? Having more
mhm.
information and having better models to supplement the actual human, uh, who actually will do the actual diagnosis is going to be really game changing. I think in the next 5-10 years.
Gotcha.
So I,
And I guess a kind of more of a high level question as far as why TensorFlow? Why not? I think you mentioned Keras at the beginning of the presentation that Silicon Valley used. Like, what's for those who are out there that aren't familiar with TensorFlow, what's it all about?
Yeah. And I mean, I think a lot of people can do a high level Google search on all the different platforms. I mean, there's like the
Sure.
Microsoft one, Amazon one, there's Keras, Scikit-learn, and I actually use Scikit-learn. I mean, these are all great, right? TensorFlow. But I think a lot of people gravitate towards TensorFlow for a couple of reasons. Number one, it runs on multiple platforms. I think it runs on like Android, it
Hmm.
runs on Mac, runs on PC. Uh, and the other thing is that TensorFlow was built to go from kind of experiments, dev test all the way to production and actually serving the model. Whereas things like scikit-learn are really good for experimental testing different algorithms and functionality. But how do you actually serve that for your business? There's no real
Right.
clear way to do that. I'm not really familiar with all the other ones, but
Yeah.
with TensorFlow, it's got the most, I think, development and involvement from the community than any others. But you never know, right? I mean, I'm trying to be as unbiased as possible. You never know with kind of open source
Mhm.
projects.
Yeah. I mean, what I'm hearing though is that with TensorFlow, there's a lot more freedom to bring it into the real world applications. or it's a lot easier to do that across multiple platforms. So that's pretty cool. We do have a couple questions in the chat. I'm not sure if you had other content for us.
No, I mean, my last one was, like, I'm very humble here. So, this last one I was pretty disappointed at. It thought that a dog inside of a hot dog.
Oh, no.
And it was 98% confident. So that's I'm pretty upset about that. So anyway,
we have some work to do on this model.
Yeah, exactly. And just to keep in mind, this is kind of the first, this is all locally done. And my next session, I'll explain how we do it in the cloud. So, not just leveraging BigQuery and Dataflow and, GCS, but actually serving it on Cloud ML and leveraging all the compute resources in the cloud. All right, let's go to questions.
Got it. Awesome. So we have a question from Oddly Ordinary, and I think you may have addressed this, but he or she is asking, are these images directly stored on the Datalab instance?
Yeah, okay. So for my case, yes, but actually the best practice is not to do that, right? The best practice would be actually to store in GCS. And none of the code in here actually changes if you use GCS. All these libraries work with GCS. So if you look at the very top, all these so this original URL would just point to a GCS bucket, and that's it. I only did this so the benefit of running it locally, it is faster by a little bit, and that's why I did it.
Got it. Okay. No, that makes sense. And we have another question from IndieCont. But uncooked sausages are hot dogs, but cooked are not.
Uncooked sausages are they really? That's news to me. I didn't know that.
Like I said, we got some training to do on this model.
Yeah. This is going to be I think this could be a religious war, but
all right, we have one last question from James Graham. Does Datalab need its own discrete storage with a copy of the data? And I think we kind of covered this, but we'll address it again. Or could you use ML on other databases in the cloud or other block or object storage options?
Yeah, so I think it's similar to the previous question. You do not actually have to have persistent storage on your own Datalab instance. Actually, everything can be stored in the cloud. So the great thing about Datalab is actually if you shut down this device, we actually store the data separately. So if you spin up, let's say, like this happened to me. I was running on a really cheap instance because I was trying to save the company money, obviously. But then I said, this is way too slow, right? So I shut down that instance and I started up a new one. And without me actually doing anything in terms of removing the disk or having to unmount it, mount it, what automatically does is when you disconnect and shut down the VM, it saves your data into a separate disk. And when you spin up a new one, it'll automatically mount that disk to the new Datalab instance. So I was able to increase my compute resources just with a single command.
That's awesome.
Yeah. So hope that answers
I think definitely. And I think that overall, I mean, just to give a TLDR again, I think we just saw a very easy way to get started with training your own models, right? And not just starting from scratch, but having this kind of interface to easily visualize both with Datalab and TensorBoard what you're doing. I think it's awesome.
No, it's great. I mean, honestly, like I'm a dummy, right? And I've only started six months ago. I mean, the only thing I might have up is, I have a master's in EE, and it's just because I like learning about this stuff. But honestly, a lot of people don't know the math, and they're doing really amazing things with machine learning. So don't get scared. Just start playing with it, and you'll quickly see how powerful kind of machine learning can be.
Hey, you heard it here first from Jonathan Cham, our brave host and presenter today, who has a master's in EE. It's coming from him. It's impressive, and I believe him and take him at his word when he says it's easy to get started with training your own models. And there's, again, awesome plug for the public data sets that are out there. I think we encourage you to just go test it out for yourself and really see what you can come up with, or pick a problem that you think needs to be solved and find the public data that's out there and begin working on it. Because, I think that, again, a lot of the legwork has been done by these frameworks like TensorFlow and made it easy to even visualize like Datalab. So it's amazing times we live in, Jonathan.
I know. Anyway, Well, look, I mean, for everyone still listening, we appreciate any feedback. GCPonlinemeetup@gmail.com. Like the video or don't like it, and let us know why. I mean, I know Anthony and I are always trying to figure out ways to improve these sessions, make it more interactive, meaningful, and just more fun. I know taking 30 minutes out of your day is not always easy, but really appreciate your time.
Absolutely. All right, everyone. Have a great day.
Thank you.